Hi friends, Assalamu alaikum. Welcome to Inside Winner. A winner is a dreamer who never gives up. Our channel gives you powerful mental tools to master tough subjects. If you are watching the channel first time, please subscribe the channel and click the bell button so that you will get notification of new videos.
Now let us discuss about railway engineering. The first trip in Indian Railway was made in 1853 between Bombay and Thane. The Indian Railways is administered by the Railway Board. Now, what is a gauge? The perpendicular distance between the inner faces of heads of the two rails forming a track is known as gauge. The three different gauges in India are broad gauge, meter gauge and narrow gauge. Broad gauge is having 1.676 meter length and it is the Indian standard gauge. Meter gauge is having 1 meter length and narrow gauge is having 0.762 meter or 0.610 meter. And the next term is permanent way. What is a permanent way? The two rails on which the train moved together with sleepers, ballast and fitting is known as permanent way. Rails are the two continuous girders laid along two parallel lines over sleepers to carry axle load. They transmit the axle load of trains to the sleepers. They provide smooth and hard surface for the wheels of a train to roll on. In India, the standard lengths of rails for meter gauge is 11.89 meter and for broad gauge is 12.8 meter. The size of the rails are specified by its weight in kilogram per meter length. Three different rails used on Indian railways are double-headed rails, bull-headed rails and flat-footed rails. Now let us discuss about double-headed rails. This type of rail consists of head and foot of the same section. This type of rails requires chair. The purpose of this type of rail was to invert and reuse them when the top table got worn out. Next one, bull-headed rails. This type of rail consists of thicker head than the foot. They require chair to fix them. Now what is a flat-footed rail? These are the most commonly used rails. These rails are also known as Vignol's rails as it was invented by Charles Vignol in 1886. In flat-footed rails, the foot of the rail is made thinner and wider than the head. They do not require chair. Coning of wheels. What is the term meaning? Coning of wheels. The art of providing an outward slope of 1 in 20 to the treads of the wheel is known as coning of wheels. The main purpose of coning of wheels is to maintain the vehicle in central position of the track. Tilting of rails. The placing of rails on the track at an inward slope of 1 in 20 is known as tilting of rails. Now, adzing of sleepers. The sleepers are cut at the rail seat to provide a slope of 1 in 20 to the rails. The method of cutting the wooden sleepers or casting of concrete sleepers accordingly is known as adzing of sleepers. Track modulus. Track modulus is an index of measurement of resistance to deformation. It is defined as the load in pounds per inch or kilogram per centimeter of the rail length required to produce 1 inch or 1 centimeter depression of the rail table. Rail corrugations. Due to defective layout, defective maintenance, sudden application of brakes, etc., a wavery surface is developed at the head of the rails and gets corrugated. The passage of trains over corrugated rails produces a roaring sound. Such rails are known as roaring rails. Hogging of rails. The loose package under the rails and loose fish plates cause the rail ends to bend down and deflect. This is known as hogging of rails. Buckling of rails. If proper expansion joint is provided, the movement of rails due to temperature change will be prevented and the rails will get buckled. Wheel burns. When the driving wheel of locomotive slipping on the rail surface, extra heat is generated and the surface of the rail may be torn, resulting in a depression on the rail table. Kinks in rails. Kinks in rails are formed at the joint of rails when the adjoining rails move slightly out of position. Creep. Creep is the longitudinal movement of rails in track. Now let us discuss about the failures of rail. First one, split head. In this type of defect, cracks are developed in the middle of the rail head or splits occur from the side to the end of the head. Split web. In split web, rail head gets cracked. And what is crushed head? In this type of defect, rail gets sagged or flattened due to defective manufacture, slipping of wheels, skidding of wheels, or inadequate support at the rail end. Now, what is a square or angular break? It is a complete break of rail. In vertical plane, it is called square break, while in the inclined plane, it is called as angular break. What is a horizontal break? Horizontal break occurs at rail ends between its head and web due to insufficient packing of ballast. Next one, horizontal fissure. Horizontal fissure occurs due to improper packing or use of worn fish plate. Horizontal cracks are formed between the railhead and the web. Now let us discuss about rail joints. Rail joints are classified according to the position of joints and according to the position of sleepers. According to the position of joints, rail joints classified as square joint and staggered joint. According to the position of sleepers, rail joints are classified as suspended joint, supported joint, and bridge joint. And what is a square joint? These joints are commonly used in straight track. In this type of joint, a joint in one rail is exactly opposite to the joint in the parallel rail. Now, what is a staggered joint? In staggered joint, a joint in one rail is exactly opposite to the center of the parallel rail. Now, what is the term suspended joint? A rail joint placed at the center of two consecutive sleepers is known as suspended joint. It is commonly adopted. Now, what is a supported joint? In this type of joint, a rail joint is placed exactly above a sleeper. And what is a bridge joint? The rail joint supported by a bridge of metal which rests on two sleepers is known as bridge joint. And these are the different types of joints in rail. Now, what is a sleeper? Sleepers are the transverse members laid below the rails to support them and keep them at a required distance apart. They transfer the load from the rails to ballast and distribute it over a large area of ballast. Now, the different types of sleepers. Sleepers can be classified as wooden sleepers, steel sleepers, cast iron sleepers, and concrete sleepers. What is a wooden or timber sleeper? These sleepers satisfy all the requirements and are only suitable for track circuiting. Teak is the best wood for sleepering purposes, but due to its heavy cost, it is used only in girder bridge for sleepering. In India, salwood is commonly used as a sleeper. Normally, the life of timber sleeper may be taken as about 12 years. Their scrap value is almost nil except for firewood. Standard sizes of wooden sleepers in India are For broad gauge, it is 2.74 meter by 25 centimeter by 13 centimeter, and for meter gauge it is 1.83 meter by 20 centimeter by 11 centimeter, and for narrow gauge it is 1.52 meter by 18 centimeter by 11 centimeter. Now the second one, steel sleepers. Steel sleepers consist of steel troughs made out of about 6 mm thick steel sheets. Its both ends are bent down to check the running out of ballast. The top of the sleeper has a slope of 1 in 20 towards the center to give the necessary tilt to the rails.
The main disadvantage of steel sleepers is that
they get rusted very quickly and it cannot be used where track circuiting exists. Their life is normally 25 to 30 years. Now third one, cast iron sleepers. Cast iron sleepers are extensively used in India. They have got good scrap value as the broken parts can be melted and remolded. The main disadvantage of cast iron sleeper is that they are liable to crack and break. The different types of cast iron sleepers are pot sleepers, plate sleepers, box sleepers, CST9 sleepers, and duplex sleepers. Pot sleepers are in the form of two balls placed under each rail and connected together by a tie bar. Plate sleepers consist of a plate of 851 mm by 254 mm in dimensions with 254 mm side parallel to the rails. Now box sleeper is similar to plate sleeper except that a box is provided on the top of each plate for holding the rails. CST9 sleeper is a combination of plate, pot and box sleeper. This is most commonly used sleeper and has been standardized by standard committee. Duplex sleeper contain two plates each of size 859 by 750 mm under each joint connected by a tie bar. Now the fourth one, concrete sleepers. The concrete sleepers are not affected by natural decay or insects, etc. They have long life of 40 to 60 years under normal conditions, and they may be of RCC or pre-stressed concrete. Now let us study the term sleeper density. The number of sleepers per unit rail is called sleeper density. In India, the number of sleepers per rail varies from n+3 to n+6 for main tracks, where n is the length of the rail in meters. In India, generally sleeper density of 18 sleepers per rail length is provided, whereas in USA, 23 to 25 sleepers per rail are provided. Now ballast. What is a ballast? Layer broken stone or any other suitable material which is spread over the top of railway formation and around the sleepers is known as ballast. They transfer load from the sleeper and spread the same over comparatively large area. They provide elasticity to the track. Now packing. The portion of the ballast which is tightly rammed under the sleeper to transmit the load of train from the sleeper is known as packing. What is boxing? The portion of ballast which is loosely filled on the slopes and around the sleepers to prevent the lateral and longitudinal movement of sleepers. It is called boxing. Now, what are the ballast materials? The materials which are generally used as a ballast are broken stone, gravel, sand, ashes, moram, kangar, brickbats, blast furnace slag, selected earth, etc. How can we calculate the depth of ballast section? Depth of ballast section in straight tracks may be calculated by capital D is equal to capital S minus small b whole divided by 2. That is S minus b by 2, where S is the sleeper spacing and b is the width of sleeper, d is the depth of ballast section. Now, rail fastenings. Rail fastenings and fixtures are used to connect rails and sleepers together in their proper positions. The various fastenings and fixtures used in the track fittings are fish plates, fish bolts, rail chairs, bearing plates, spikes, anchors or anti-creepers, blocks and keys. Now let us study about each term separately. Fish plates. Fish plates, fish, fish plates are used to connect rails at their ends. What about fish bolt? At every rail joints, fish plates are connected to the rails with the help of fish bolt. With each pair of the fish plates, 4 or 6 fish bolts are used. But on Indian railways, 4 number of fish bolts are used. Now third one, rail chairs. Rail chairs are used for holding DH and BH rails in the required position. They distribute the load over a large area of the sleeper. The chairs are generally made of cast iron. Now fourth one, bearing plates. They are used to distribute the load from flat-footed rails over wider area of wooden sleepers. Fifth one, spikes. Spikes are used to fix rails to wooden sleepers. They are of different types: dog spikes, screw spikes, round spikes and elastic spikes. What is a dog spikes and where is it used? These are square spikes. Legs are provided at top for extraction. The lower end of the spike may be pointed, blunt or chisel pointed. They are used for holding flat-footed rails to wooden sleepers. Now screw spikes. These are tapered screws with V ends. The holding power of these spikes is more than dog spikes. The length of these spikes depend on gauge. For broad gauge track, 165 mm long spikes are used. Now round spikes. Round spikes are used for fixing chairs of BH rails to the wooden sleepers and also for fixing slide chairs. Elastic spikes are provided with a steel spring, that is elastic spikes. Now the sixth one, anchors or anti-creepers. Anchors are provided to prevent the creep of rails. Blocks. Blocks are used to provide flangeway clearance between the check rails and stock rails. And keys. Keys are used to fix the rails to the chairs. They may be metal keys or wooden keys. Now let us discuss about track design. Track should be designed in such a way that trains with heavy loads can run over it at maximum possible speed. While designing a track, safety, comfort and speed have to be considered. Now formation. The top width of a track in embankment or bottom width in cutting is known as formation width. The formation width depends upon the gauge of the track, number of track and the space between the tracks. Indian Railway Board have recommended the following dimensions for broad gauge. Minimum center to center distance of track should be 4.725 meter. Minimum formation width in embankment for single line is 6.1 meter. Minimum formation width in cutting for single line is 5.490 meter. Minimum formation width in embankment for double line is 10.82 meter. Minimum formation width in cutting for double line, excluding side drains, is 10.058 meter. Now side slopes. The slope given to the sides of the earthwork in embankment or cutting for its stability is known as side slope. The usual slope provided in cutting is 1.5:1 and 2:1 in embankment. Now let us discuss about gradient. The rate of rise or fall of the track is known as the gradient. The gradients in railways are classified as rolling gradient, momentum gradient, pusher gradient and station yard gradient. What is a rolling gradient? The maximum gradient to which a railway track may be laid in a particular section is known as a rolling gradient. On curves, the gradients are reduced to avoid the extra resistance. This reduction in gradient is known as grade compensation on curves. In India, the rolling gradients provided are in planes, that is gradients provided as 1 in 150 to 1 in 200. In hilly tracks, it is 1 in 100 to 1 in 150. Now, momentum gradient. A falling gradient is usually followed by a rising gradient. On falling gradients, trains get momentum, and this momentum can be utilized for rising gradient. The gradient that utilizes the momentum from falling gradient for the following rising gradient is known as a momentum gradient. Pusher or helper gradient. The gradients that require extra engine to push the trains are known as pusher gradient. Now, station yard gradient. As far as possible, the gradients are avoided in station yards because extra force is required to pull the train on gradients, and if high wind blows, the bogies may begin to move, resulting accidents. The maximum gradient in station yard is fixed as 1 in 400. Indian Railways recommended a gradient of 1 in 1000 at station yards for easy drainage. Then, what is the super elevation here? In a railway track, the raised elevation of outer rail above the inner rail at a horizontal curve is termed as super elevation. It is also known as cant or banking. Now, equilibrium cant. If the super elevation is provided such that the weight of the moving vehicle and centrifugal force passes through the center of the track, it is known as equilibrium cant. And what is a cant deficiency? The difference between equilibrium cant required for maximum permissible speed on the curve and the actual cant provided is known as cant deficiency. And what is a negative cant? At places where branch line meets the main line on curves, the outer rail of main rails will be higher than the inner rail. Hence, the outer rail of branch line will become lower than the inner rail, which is the reverse of the requirement. Such super elevation is known as negative super elevation or negative cant. Now, cant board. Cant board is used for providing super elevation on tracks. Now, let us discuss about the term points and crossing. Wheels of train have flanges on the inner side to prevent lateral movement of train and allow them to move in one definite direction only. Hence, special arrangements are necessary to divert a train from one track to another. These special devices which are required to divert a train from one track to another is known as points and crossings. Stock rail. It is the fixed straight rail in a track against which tongue rails fit. Now, what is a check rail? These rails are provided on opposite side of crossings to prevent the tendency of the wheel to climb over the crossing rail. Tongue rail. It is a tapered rail having toe at one end, heel at the other end. It fit against that stock rail. Now, splice rail. Splice rail is the rail of the branch track which meets the point rail at the nose of the crossing. What is a lead rail? These are the length of the rails from the end of the tongue rail to the toe of the crossing. And wing rail, the two bend-up rails of the crossing which are connected to the ends of the crossing lead rails are called the wing rails. And what is a heel? Tapered rail where they are fixed to the main rail are known as heel. Heel divergence. Heel divergence is the distance between the running faces of the stock rail and gauge faces of the tongue rail when measured at the heel of the switch. Now, what is a toe? It is the movable end of the tapered rail. What is a flare? It is the tapered widening of the flangeway which is formed by bending and splaying the end of check rail or wing rail. Now, flangeway clearance. It is the distance between adjoining faces of a stock rail and check rail. Flangeway depth is the vertical distance between the top of the surface of the rail to the top surface of the blocks provided for keeping the flangeway. Facing direction. When the crossing is seen while standing at the top of switch, the direction is known as facing direction. And what is a facing point? A point is called facing point when a train runs in facing direction only. And what is a trailing point? These are the points where the train passes over the crossing first and then over the switches. Studs. The bend-up plates fitted to the web of the stock rail for preventing lateral bending of the tongue rail. And what is a point rail? It is the main railway track forming the nose of crossing. Throat of crossing. This is the place where the converging rails are at the nearest position. Nose of crossing. It is the point of intersection of point rails and splice rails. Top of crossing. It is the end point of a wing rail with lead rail. Slide chair. These plates are used to support the tongue rail throughout the length and permit them to slide easily. Now, what is a stretcher bar? This is the bar connecting the top of both the tongue rails and allows them to traverse the same distance at a time. And what is a switch angle? This is the angle between running faces of stock rail and tongue rail. Turnout. It is track assembly used for diverting train from one track to another. Now let us discuss about signaling and interlocking. Now, classification of signaling. Signaling are classified according to operational characteristics, then according to the functional characteristics, then according to location characteristics and special signals. These operational characteristics are again classified as fog or audible signal or detonating signals, then visual indication hand signals and visual indication fixed signals. According to the functional characteristics, it is further divided as stop or semaphore signal, warner signal, shunting signals and colored light signals. According to the location characteristics, signals are classified as outer receptional signal, home receptional signal, starter signal and advanced starter signal. And according to special signals, they are classified as routing signal, calling on signal, point signal, repeater or coacting signals, modified lower quadrant semaphore signals and miscellaneous signals. These are all about railway engineering. Guys, if you want more videos for the coming PSC exams, please write below in the comment box. If you are not subscribed to the channel, please subscribe the channel, press the like button and share to your colleagues. Don't forget to press the bell icon so that you will get notification of our new videos. Thank you.